Alex. He's a Google Developer Relation Engineer, and at Google, of course. And his topic will be Firebase and GCP. Hi, Alex.
Hi, Sardor. Hi, everyone. Does everybody hear me okay?
Yes, I see they can hear you well, because I also can hear you well. Yeah.
Awesome. Cool. Let's get started. Today, I'll be talking about Firebase, first of all. I'll also be talking a lot about the way some things work under the hood and how it's connected with the Google Cloud Platform. A few minutes ago, I also heard there were a few questions around actions on Google and about storing data, maybe integrating it. So I'll touch that a little bit as well, since it's a fresh topic that has been discussed. And at the end of my presentation, I'll be happy to answer questions. So without further ado, let's start. The presentation is composed of two main sections. The first section contains a quick, a brief about the difference, what is Firebase, what is GCP, and why we use one or the other at a broader scope. And then we'll go over each Firebase product into some detail, and I will explain how each product would come and integrate into a broader concept, into the big picture of having your solution deployed and ready to delight your customers, and also hopefully keep you out from the cold water. Yeah, so what is what? Firebase is an app development platform. So the main focus, the mission, our goal is to make sure the mobile, web, and any other supported platform developers are, first of all, successful. So that's the main focus. Everything else is just tooling that helps us achieve this mission. By contrast, cloud computing services or cloud platform mission is to enable organizations to have a smooth transition into the cloud, essentially allowing them to focus on delivering services and not have to worry about infrastructure. So if we compare this with Firebase, it's immediately visible that cloud platform focus is primarily on just providing all the technical means in order to get stuff done from a service point of view, be it a backend server, be it a service as a platform offering, be it something else. Essentially, we want to get stuff done when we talk about cloud, and we want the apps to be really delightful without too much stress when we talk about Firebase. And because of these differences in mission, the way we achieve these goals are quite different. For instance, when we use Firebase, a big focus is on having these really nice native SDKs that would offer a delightful experience. And as of right now, we support iOS, Android, Web, C++, Unity at the main platforms. And we have quite a few of the community contributed SDKs to enhance that for many other platforms. By contrast, Cloud Platform doesn't really offer much SDKs. There are a few exceptions for some products, but generally it doesn't really offer a lot of SDKs. What it offers, however, are really good services and APIs that can be called, usually in form of RESTful API that you can call from your backends. And also, in order to make these calls easier, there are also some SDKs and some libraries offered. But yet again, the focus for Cloud Platform is to just make it really delightful to work from the backend, not necessarily make it easy to create client code. And because of this fundamental difference, there are a few other differences which result immediately out of it. First of all, Firebase is much easier to get started. You would normally be able to just get up and running in a couple of hours after just hearing about the existence of Firebase. With Cloud Platform, you can probably follow through a getting started guide or some kind of code lab, and then you'll also have some stuff working, but it will take a little bit longer to just get comfortable with it. Firebase also has a very strong focus on offering front-end accessible services. That is, things that you can use directly from your app without needing to write any kind of backend code. So our front-end our databases in Firebase have security rules that allows the clients to securely interact with them. By contrast, Cloud Platform, which also offers a pretty solid system of access and administration that has roles and also has audits, which, for instance, Firebase doesn't offer out of the box. Cloud Platform, however, does not offer any means to make these easily accessible from the client. So you have to essentially use something like Firebase or build your own stack if you want to expose some of that infrastructure, some of that functionality to any of your clients. Also, because of this, Cloud Platform offers a lot more control over how you configure your infrastructure. And of course, you can control how fast and by which strategy things will scale up and how things are interconnected. By contrast, Firebase does a lot of things for you. It's quite opinionated on how things should work. And you'll see as we go through the products that a lot of these decisions can be overridden, but then you'd be essentially using mostly cloud stuff rather than the Firebase native SDK features. Okay, so let's have a closer look at Firebase. Historically, Firebase started as a developer product, then we added more stuff to it, and we created these three pillars of development, of quality assurance, and of growth. And over time, these were modified slightly. But the main focus stayed the same. We want to offer an end-to-end delightful experience for all the app developers. Okay, if we just start from the left, the first product in there would be Firebase Auth. There we go. And this is fundamental because Firebase being a front-end database, it really needs a way to make sure we're still secure and things can be controlled and planned. Security can be planned, and there are guarantees that things won't just go hectic once in production. So Firebase Auth is probably the most important and the primordial product we have. And it's essentially an identity as a service offering. What means is that out of the box, you get an authentication UI, which currently is available across a few platforms. So you don't really even have to even write the UI yourself. You can just include one of the Firebase UI libraries, and then everything is essentially done for you. Of course, you can also customize this, or you can skip it altogether and do something like your own UI or even your custom authentication. And Firebase supports a bunch of popular IDPs. However, and here is the first difference versus the cloud platform, Firebase does not support the more advanced enterprisey things. So for instance, if you want to configure a SAML, a single sign-on mechanism, then you'll have to use a cloud identity interface. And by interface, I mean you have to actually go to the cloud identity website and configure it from there. While if you look at what happens when you enable an authentication method in Firebase, that is both supporting in Firebase and cloud, you'll see that it would appear in both platforms. Firebase does not support all of the authentication methods that Cloud Identity has. So that would be a reason to use cloud. If, for instance, the thing you want is not supported and you don't want to have a fully custom auth implementation, which you can do, of course, by just using Firebase. Yet again, if you're an enterprise that just wants things to work and they have a requirement to have SAML, it's probably the easy way to do it. If you want to just kind of have to experiment or have more control, you can always go with custom auth as well. Yeah. So another reason to consider Firebase versus Cloud Identity is that with Firebase, you can start for free without a need for a credit card. So you can accept people logging into a system without having to create a so-called billing account. A billing account is essentially just a registration in which you provide a payment method so that in case you run over the free quotas, there is a way to make sure we can continue to provide services for you. So this is essentially one of the differences from cloud and Firebase. That Firebase is generally offers more of the free stuff without requiring a credit card. GCP will require the credit card even if you're never gonna actually go beyond the free tier limits, because unlike Firebase, it will not actually prevent you from going over. When you use cloud platform, you'll essentially have access to everything. And unless you have some automation to prevent, to stop some services that are running, if those servers are used and they go above quota, you'll get charged. So this is one of the main fundamentals here. Now, worry not, you can still trial both of them for free. You can go grab, I think currently it's $300 US of credits, and just try out and play with both platforms. And if you like them, when your credits run out or when you were in a few months when they expire, you can just keep using it. And if not, you don't have to do anything. When credits expire, your project will essentially just be downgraded to the free offering, which means Firebase will continue to work and some cloud things might not. Okay. So now that we got all of this off the plate, let's also look what else is happening. Okay, so generally you won't really have to switch from Firebase to Cloud Identity Provider once you start using one of them. However, if you start using Firebase and later you decide you want to use Cloud, you'll actually have to go and enable that service in the Cloud Identity. This might not be intuitive if you're not used to the way things are set up, because you'll see the project exists, but for some reason the identity is disabled in cloud, but then Firebase somehow works. Like, worry not. When you enable, you won't lose any of the configuration from Firebase. It will just allow you to access to the cloud identity provided that are not available in Firebase. Yet again, and the same applies when you downgrade a project. If you downgrade a project, then the Firebase stuff will continue working while the cloud stuff would be paused until you have a billing account set up again. Okay. Cool. So we know that we can do authentication pretty easily with Firebase. And since Firebase will know who we are, it allows us to have really simple to set up things like the very first product that made Firebase popular, which is a real-time database. Its main features are, first of all, the ability to store and sync data in real time. So you don't have to worry about fetching or pushing changes yourself. All you have to do is, if you care about something, you just subscribe to it, essentially. That's it. When changes happen on the server, they push to all the clients who are listening. In order to make this happen, the database had to be a NoSQL. It's much harder to do this kind of stuff with a SQL database. Also, to keep things real simple, the entire real-time database is just one big blob of JSON-like data. And this also has a few advantages. For instance, the fact that the data has such a simple structure allows us to have optimizations that that might be useful in cases when your data changes a lot. So for instance, if you have some kind of data collector, IoT device, or if you have an online presence, a tool that would have to override some keys with data very often, say couple of times, a few times every few seconds, then real-time database is great because it's really good at propagating these changes. And of course, it supports security rules. The security rules in RTDB real-time database are a little bit simpler than in the other offerings, which might be an advantage or a disadvantage. The advantage is you get to start faster. Disadvantage is, well, they're a little bit harder to maintain. Okay, so like I said, the structure is pretty simple. That means you can store data. You can't really store a whole lot of it. Like you can't really store terabytes of data in here because it's just one big blob, and well, it's not meant for that. So what do you do? What do you do in one of these cases when you really need to store a lot of data, or you want to have more structure, or you want to have better querying capabilities than just looking up some values in a tree? Well, in this case, you might want to migrate a portion of your data from the real-time database to something else, or you might decide to just start with a different database, or start with both real-time database for things that change a lot, but are not read too often or searched through, and then Firestore for stuff that's more of a stateful thing. For instance, your user profiles, all your user activity, and only keep RTDB, for instance, maybe for online presence detection or for status updates. It's up to you. Generally, the main idea is that you can easily export the data from RTDB, and if you want, you can use that alongside, or you can write your own logic to implement the features that it offers. It's really up to you. The first thing to consider, if you feel like RTDB is not enough, is Cloud Firestore. Now, Cloud Firestore is actually called Cloud Firestore, even though it's in Firebase. I know, it's confusing. And the reason is that Cloud Firestore was implemented directly on the cloud platform, even though it was implemented to be used in Firebase. So that's why it got its naming of Cloud Firestore, because it's actually run on the cloud platform. But we also call it a Firebase product because it has some features that are only available when you use it from Firebase. Okay, so let's actually look over that and see what the deal with those features. Okay, just like RTDB, it stores data in real time. It's also NoSQL. It also supports security rules. This time, the new improved security rules. It has really good offline handling capability. It scales automatically. And it's great for storing structured data that you read more often than you update. So, which is probably 90% of all the data that you'd work with. One thing that it is not great at is for things like analytics or data that needs to have cross joins. And I'll explain quickly why that might be an issue and how you can solve it. So the way data is organized in Firestore is in documents, and documents are in collection, and then each document can have its own sub-collection, which means the data is really easy to access once you have a mental model of how it's organized, and you don't have to keep your data normalized. It's up to you how you organize it. Generally, the expectation is for you to just organize the data in a way that's easy for you to read and filter and query. That's the rule of thumb. And really, that's how you'd approach Firestore from a design point of view. Now, sometimes you might wonder, okay, how do I actually do more complicated stuff with data? Like, for instance, I maybe want to have a search engine, a mini search engine to do some kind of searching inside my data set. And the answer is, if your search is something simple, like just look up by a value or read the last 10 items from a collection, that's easily done with Firestore. If you, however, want to have something more of an analytical platform, then I would actually recommend you to keep two databases. One would be the Firestore, which is your primary thing that your app will use. And then you can have something like a BigQuery or another backend database that you will, or maybe a full text search engine that you will only use when you need to do these more complicated queries for your business logic. And you can and you'll essentially just create a mini microservice by maybe using Firebase Cloud Functions, which we'll review in a minute. And that should probably be it. Like that should be enough to have this working. And that's probably the moment when you want to look at at adding some cloud platform stuff on top of Firestore. It's when you see that Firestore is not a perfect fit for all your user journeys. So let's sum it up a little bit. Firebase uses Cloud Firestore, and it uses it in native mode. If you go into Cloud and you check Cloud Firestore, you'll see that there are two ways in which you can enable it: native mode, and also it can work in data store mode. Yet again, this confusing terminology has some legacy reasons why it exists. What you want to remember is that Firebase Firestore always works in native mode. And second thing you want to remember is when you choose a mode, you cannot change it later. So when you create your project, if you plan to use that project for Firebase stuff and you have Firestore database in it, just enable it in native mode. Later on, if you need to use something for backend, you can always create another project. It will just be easier for you to manage data this way. It's much easier to reconfigure your backend than to have to redeploy your app because you need to change your front-end project. So the recommendation is start from the front end, configure it in a way that's easy for you to use from the web, from your app. And if you need, you can always create additional projects for the backend stuff. And you can pretty easily connect them with one another. If you don't need multiple projects, it's fine to keep one project per environment. So have one project for production stuff, a project for staging, a project for test, and so on. Okay, cool. So we know that what Firestore is. We know that Firebase uses it in native mode. And we also know that we can't really switch in between. So what do we do? What do we do if we need to actually to have this kind of communication? Well, the first and easiest way would be to just have some job that would automatically export data into something else. Like for instance, BigQuery. I like BigQuery to use BigQuery for analysis. And if that's not good enough for you, you can use any of the other databases that are available in cloud. I think there's 5 or 6 of them, and they cover a pretty broad range from simpler to use SQL databases to more complex distributed SQL stuff to big data analysis tools like BigQuery and to read-only databases that you just normally use for looking up archives. So you have a pretty broad range. I would say just start with the SQL database that you think is closest to your business requirements and has the easiest API for you, and you should probably be fine. Okay, so that's pretty much it for Firestore. Let's go and look at what other things we have. So the next big thing is cloud storage. Think about it as a service that allows you to store things that are too big to fit in Firestore efficiently. Normally, that would be files, sometimes media. Generally, it will be assets. And just like Firestore, it has support for security rules, and it has decent caching. It scales automatically. The one core difference to remember is that it does not have the real-time notification component in it, which I guess should be fine. But you just have to remember that if you want to get notified about changes in a file, you'll probably have to also create an entry for that in the Firestore. You'll be fine. Now, in order to Now, cloud storage itself is also, of course, part of the cloud platform. Pretty easy to figure that out looking at its name. One thing to remember is that when you use cloud storage from Firebase land, you have access to the security rules. When you use cloud storage from the cloud land, you don't have access to security rules because the access will be restricted to only your backend authorized processes. However, you'll get the benefit of having more flexibility around how you configure the platform, how you integrate it with your backend processes. So, and you can also use the same bucket of cloud storage in both platforms at the same time in order for you to have a more smooth workflow. Okay, a big thing that I wanted to touch down on is cloud functions. Cloud functions are probably the pinnacle of Firebase. They're really the one product that allows you to go above and beyond what's natively supported and integrated with pretty much anything you can think of. Currently, we only support JavaScript as a language of choice for cloud functions for Firebase, and when you deploy functions, we essentially create containers that are deployed into cloud platform and run your backend code in there. This should be a good option to get you started. You might find that eventually you would want more control or more flexibility on how you organize this, and that's where cloud might really help you. So cloud platform, while offering the cloud functions functionality to Firebase, it also has a lot more on top of it. You can run other languages. You can control the lifecycle of your containers. You can automate a lot of these as well. So, for instance, while with Firebase, you essentially just redeploy stuff, and the containers get rebuilt. With cloud, you actually have full control over the lifecycle. You can decide. You can roll back to a previous version easily, and so on. So you have all these control. But it comes at a cost. And the cost is that the API is not quite as easy to use, especially when you're just getting started. So Cloud Platform has this great flexibility. At the same time, the price you pay is that you have a steeper learning curve. Also, Cloud Platform does not offer quite the same API for integrating, for writing those triggers, which are the equivalent of hooks in other environments. That means whenever something happens, your function can be called. And probably the most popular usage for them is to call those functions whenever some data changes in your Firestore. So if a user writes something to the Firestore database and you want to act upon this, for instance, you want to do an API call to a third-party service and get the customer some kind of result, it's very easy to do with functions. You can also use that to export data or to import data from other systems. So it's really up to you how you use it. And in order to use it with Firebase Firestore, I would strongly recommend to use the Firebase SDK tooling. But then you can use Cloud Platform tooling to do later on to do some continuous integration, automations, that kind of stuff, or to deploy additional containers that are not natively supported by Firebase. Okay, let's move to something that's hopefully simpler, hosting. It's what it sounds like. It's fast, it's secure, it's distributed with a global content delivery network. It offers free SSL certificates. Hey, and you can use your own domain. That's a pretty neat offering. One flaw is that it does not provide out of the box any kind of dynamic page generation other than just allowing you to forward your request through rewrites. Now, the rewrite mechanism, while it seems pretty simple, it's actually very powerful because the rewrite can transparently proxy your request to pretty much any web endpoint of your choice. And this can easily be a cloud function or a container that you're running in cloud. So you really can run any kind of backend infrastructure for your complex computations in the cloud, and then not have to expose it directly, but instead just rewrite some of those calls to those and send them to those backends, and it works as simple as it sounds. You will still use your internet domain, and the customer might not even realize that they're actually hosting in a different place. Okay, and as of recent, we also offer access to logs, which should be pretty cool. There's not a lot for me to talk about integrating this with other integration with Cloud Platform, since Cloud Platform itself does not offer hosting per se. But yet again, it offers containers, and you can use containers for hosting anything you want. Next, machine learning. Okay, machine learning is one more interesting story. Okay, so the idea here was to offer a very easy entry into applied machine learning for app developers. So we came up with a few things which were on the device and in cloud, out of the box, pre-trained models that you can use. And then we saw that that's not enough, and we also added support for custom models. And we saw that custom model might be a little bit difficult for people who use machine learning for the first time. So we offer something in the middle, in which we take a pre-trained model, for instance, for detecting images, and then we allow you to customize it with your own data set. This way you get the best from both worlds. Now, after a while, things grew up and they became a little bit complex, so they got split. The stuff that happens on device now moved to a different project, which is called MLKit. So before it was called Firebase MLKit, now it's called just MLKit, and it's a separate thing. At the same time, Firebase still has a machine learning component, and it's the component that makes things easy for you to get started with. So it has these pre-trained models. It has this nice UI for doing your AutoML training, that is taking a model that was pre-trained by us and then fine-tuning it for your own data set. And it also hides away some of the complexities of hosting and deploying your models using the cloud platform. What you end up doing is just clicking a few buttons in the console UI and then writing a few lines of text in your app, and they just work. However, over time, you might realize that might be not enough for you. And in that case, cloud AI is really the thing that shines. So once you have this experience that you got by just getting started to work with this model with Firebase, you'll already have the intuition of what goes where. And then the entry into using cloud AI will be so much easier. So really, that's a very natural course of things to start with Firebase ML, see what you can do with that. And if at one point you want more flexibility, just look in the offering for that comes from cloud. And it should be pretty easy to figure out what you want. So if you already used AutoML from Firebase, but you found it not being customizable enough, take a look at the AutoML in cloud. If you decide that none of the stuff actually works, look at custom models in cloud. But you can still use Firebase to deploy them. And if you just found a really great pre-trained model, well, you can use it directly and then employ a cloud function to connect the cloud AI stuff to your Firebase database. So it will feel like a normal progression, and it won't be too overwhelming. I've gone through this, and after a while, it seems pretty natural. Okay, one more thing, which can get you started real fast on the more advanced topics are Firebase extensions. Extensions are features that are not big enough to make for a product, but are also popular enough to make them reusable. And a really good thing about extension is that you can actually see the source code for them. They are open source. And that means that you can take a look and see how they're implemented. And if you find something that looks kind of similar to what you'd like, that could be a great way to get you going. So you can install the extension, see if it does the stuff you expect. If it does kind of does what you want, you can look at the source code and customize that, and then just deploy it through Cloud Function on your own project, and it will work. You can, of course, use the extension out of the box. Google Cloud does not come with this thing out of the box, but you can still automate a lot of things there by using many of the integrations that are supported in cloud. Yet again, you can do way more there, but it will require a bit more learning to get there. Okay, let's quickly look at other products. These ones don't really have a direct alternative in cloud. However, they're still pretty well integrated. So for instance, Crashlytics, our crash reporting tool, has a BigQuery export, a data export option. And this BigQuery data export option is present for a lot of the other data-intense data gathering Firebase tools. So if you're using a Firebase product and it's gathering data from your users, and you feel like Firebase is not enough for you to do the proper analysis over that treasure chest, take a look at the configuration and see if there is a BigQuery option, BigQuery export option. Now, when you toggle that on, you'll probably want to be careful on where you put the data, because those data sets are pretty big, especially if your app is popular, if it has a lot of traffic. So you want to do some analysis before just toggling it on, especially if you're toggling on both the if you're toggling on the real-time export as well. Now, once you have the data in BigQuery, you should be able to easily analyze it using another product, which is called Data Studio. And it's such a great thing. It would be worth just watching a presentation on just about Data Studio and how it works and how you can use it to make data science application easier for you. It has a great offering of tools, and it has also samples for open source data sets, so you can get started without even having to use any of your data. Okay, Firebase performance. Like Crashlytics, is to make its primary mission is to make sure our customers are happy. Essentially, all your users are happy. And it offers a bunch of tools for that. And you can export the data it gathers. One thing to remember is that Cloud also offers performance monitoring tools, but for Cloud, it's all for the backend. And with Firebase, it's all for the front end. So depending on which service you want to monitor, you would be using one or the other. TestLab, for running your apps on a bunch of devices or physical devices in the cloud. Now, TestLab also has an interesting story. It was initially part of Cloud, but then it was moved to Firebase because it just made a lot of sense to be in Firebase, the platform that's for app developers. It wasn't really a cloud thing. It was more of an app thing. But because of it being in cloud, it means it also relies on the infrastructure from cloud. For instance, it uses cloud storage to store artifacts. And by artifacts, I mean things like screenshots and reports of your test runs. I don't know of an easy way to export data into something like BigQuery. However, since everything is stored in cloud storage already, it's pretty easy for you to download. And you can also use Cloud Functions to integrate this with your continuous integration system or whatnot you're using. Okay, now let's talk a little bit about growing users. So probably the most popular offering that Firebase has for this pillar is the Google Analytics integration. Yet again, the UI is great. If it's not enough, take a look at the BigQuery option for export. One of the weird things about analytics is that historically it's been named differently. And to be honest, most of the time on the naming change, actually some functionality changed as well. So you maybe heard about analytics, Google Analytics for Firebase, Firebase Analytics. Yeah, so they're pretty much the same product, but they have different sets of features. So I encourage you to just look at what the latest version was currently supported, which is this version, and see if this, and kind of look at the feature and see if this is what you want. Also, if you have legacy projects that were created before, you might have an older configuration. So essentially, while the product works kind of similarly, there might be slight differences in the way APIs work. So if you're already a seasoned Firebase developer, you might discover that you need to refresh your knowledge just a little bit if you have a big migration here, or you're starting a new project. Not a lot of stuff, just kind of be mindful that this product evolved over time and it just a little bit changed with each major release. Okay, cloud messaging. That's probably the other second most popular thing in this pillar of products, and just like the previous ones, it doesn't really have much of an equivalent in the cloud platform. Firebase Remote Config offers, the next one, it offers an option to send different configurations to the clients. Now, the really cool thing about this is that it made possible a few other products. For instance, A/B testing and other interesting mixes. It's especially powerful when you combine something like this or A/B testing with analytics. Then you can have a certain level of business intelligence and automation implemented really easily. I encourage you to just go ahead and read about each of these products if that's something that if you're at the stage in which you want to grow your app's audience. I won't go into detail because it's off topic for today's presentation. Okay, and probably the only product I want to just talk a little bit about in this from this family is the predictions. Predictions really is kind of a zebra giraffe thing because it has some ML, but then you don't have a lot of control over it, and it has remote config and analytics and cloud messaging integrations, but yet again, you have to set it up. But the really cool thing is it allows you to do really interesting and complex experiment that normally you wouldn't do without a heavy investment. And with prediction, it's just so much easier. One of the classical example would be to predict which users will stop using your app sometime soon, and then do something about that. And this kind of prediction works really, really well, pretty simply. All you have to do is just have a big enough base of users and also have enough events, so enough interaction that the users do with your app. So for instance, if you use Google Analytics and you have a game and you're using analytics to log every time a user progresses in your game, or they do a certain kind of choice, or they do another operation that changes the progression of their story, these signals should really help the system figure out if there are any patterns. And if there are patterns which become frustrating for the users and they decide to not use your game or your app because it doesn't really cut it, this should surface rather fast. So really give it a try. If you have a big customer base, or when you have a big customer base in the future, if you don't already, just give it a try. See if you can get some stuff that you maybe didn't expect by just putting it out there and just letting it run for a while. And once you get some signals, play a little bit with it. Play a little bit with FCM, maybe with A/B testing. See what works. It's really a cool thing, and I don't think there's quite anything like this that's so easy to deploy and get the same kind of business intelligence right in your hands with minimal effort. Okay, so that's what I wanted to present you about Firebase, and I'll be happy to hear any questions that you might have. I think we still have upwards to 20 minutes, so that means probably up to 10 questions.
Yeah. Thank you very much, Alex, for your presentation. Before audience will give their own questions, I would like to start with my own. As you know, in Firebase, we have like different type of platforms to authenticate, like Apple ID, Google+, Facebook, and GitHub. Can we somehow integrate our own like platforms?
Yeah, absolutely.
For example, I have a platform. Yeah, I have a platform, and I would like to add the inside the Firebase or Firebase authentication SDK my own platform's signing logic.
Okay, yeah, absolutely, you can do that. Actually, there are many different things that you might do in order to integrate custom stuff, but probably the most popular, the most common workflows would be these. One workflow would be to just integrate an OAuth provider or SAML provider that's not supported out of the box. I mean, if you have the code if you have a Node.js code that essentially does the integration, that is that OAuth server-side client that does the integration for you, calls the server, gets the code, the token, and persists it somewhere. Really, all you have to do is just create that in form of a cloud function, deploy it using Firebase, and then from within that function, you call Firebase Auth API, which is called the create custom token. I think it's there's a pretty good help article there with working with custom tokens. So what you do, you call this API and say, I want Firebase to authenticate this user under this identity with this in this scope, and it will work. And you can do this with any other system as well. For instance, I have a blog article about an experiment I did with IoT devices in which I took an Arduino and authenticated the device using its device key pair with Firebase Auth. And all I had to do was write one function in cloud function and deploy it through Firebase, and it worked. So definitely that's possible. There are a few really cool help articles there, and I'll also look into maybe doing more write-up on this topic.
I see. That would be great. And another one, a couple of months ago, here in Tashkent with the team, we did image recognition. To be more exact, we tried to read the text from image, from camera. So in order to do that, we used Firebase and Firebase ML kit to do that. And we were forced kind of, in order to read the text, we need some models, right? So we trained that models, we provided that models by ourselves, by our platform. And when the user wants to read some image, when user wants to scan some image in order to read the text, we forced the user to download like 10 or 5 megabyte models to their phone, and then read the text from the camera, from the image. So either any way to do that within Firebase, like locally?
Yes. So there are a couple of ways to do that. The simplest way is to just, assuming the language that you're targeting is supported by the default models, is to just use the MLKit language API, in particular the text recognition API. The way it works is that when you build your app, you have the option to configure it so that you can pre-download a model and ship it with your app, so you don't have to have an additional download. You can also skip this step and just download the model after you start the app. And Firebase can take care of a lot of the things. For instance, checking for new versions of the model, downloading it in the background, if you allow it to do that, and also using an on-device model and a cloud model for at the same time or whenever, or depending on your logic. So there you can also run the model in the cloud, especially if it's a really big model, and if it's not a smooth experience on the device, you can have this kind of hybrid option in which the performant devices that already have the model downloaded, they would run it locally, but then for other users, they might actually upload the asset and let it process on the cloud. It's up to you how you configure it. Firebase MLKit in particular allows you this flexibility of deciding on where to run stuff, and Firebase also allows you to have some control over where you run stuff. Yeah, that's probably the answer. There are quite a few models right now that already do this text recognition pretty well, so you probably won't have to have your own custom model. But it's up to you to decide how you wanna configure it. Generally, from my experience, the best practice would be that depending on the format of the document and the stuff that you want to run text recognition on, you might want to have two different models for that. One would be to just find the regions of interest, the regions that have the text that you want recognized, and kind of ignore everything else. And then have another model who actually does the text recognition. Generally, this setup works really great, particularly for things like noisy backgrounds and for documents with certain formats.
I see, gotcha. And I think from my side, that's enough. Let's go to audience. I see that from the audience, there's not much questions. So let's see if they will have questions. If not, then we can wrap it up and we can finish our session. And yeah, I mean, I like the Firebase because Firebase helps you to do most of your backend stuffs without having actually backend guy. So it's always written, and it's very helpful to build MVPs most of the time. So in order to in order to check your product is useful your product or not, you can just have one mobile developer guy and check it with them. So and it's a cool product. I think most of the developers like this Firebase.
Yeah, I think the really great thing about it is that it allows for people who are not necessarily backend developers to start doing stuff that is full stack. So, for instance, if you're an iOS or an Android developer and you really know well your platform, but you don't have a lot of background or a lot of experience in the backend realm or in cloud, you can get started, have a really professional product created, and if later on you need to do some backend work, which this presentation was about, like what do you do when you outgrow some of the features, or how do you make sure your backend is really the best it can be? That's when you can employ additional help or study it yourself and kind of have a lean transition into having more advanced features while also keeping your application in production and running.
Yeah. I see that we don't have any questions, so we can wrap it up. Time and for your presentation. I think it was helpful for a lot of people out there, and we hope that we will see you in our next events and presentations. And yeah, thank you very much. Again, Alex is a developer program engineer at Google, and he talks most of the time. His talks is mostly related to Firebase and GCP. Thank you, Alex, very much.
Thank you, Sardar.